So I've been responsible for probably 8 projects in town so far. This is by far the most complicated. The size, the location, the sheer number of folks that are affected by it, and the dollar value. It is a significant project for the town. So it's really twofold. It's one based on enrollment. Right now we have 2,425 kids in the building. That's really built for 1,850 students. It's just too small. We have students that are in sub-sized classrooms. They're in classrooms that are 650 to 700 square feet, where the standard is 900 square feet. We have students that are in 2 separate cafeterias, and because there's not enough seating there, they eat in the corridors. They eat in the gymnasium. They eat while they walk. There's not enough seating to do that. The gymnasium is 9,000 square feet. The new standard is 18,000 square feet for the number of students that we have. It's half the size. It's just too small. In addition, the building was built about 75 years ago. We did a renovation in '99 that did a little bit of square footage addition for some of the cafeteria spaces and some secondary spaces behind the theater, but we didn't add any classrooms. And what we really need right now is additional classrooms. Those systems are 25 years old. They're getting tired. The systems that are the most fragile at this point, the roofing system is 25 years old. They have about a 25-year life. We have active leaks in the buildings. We have an on-call roofer that spends a lot of time on the roof finding and patching the holes that are in that roof. With the age of the systems, they're not modern technology. They're about 25 years old, so the expansion-contraction ratio of the materials that were then, they're failing. And so patching them is one thing. We can do that, but the patches of the patches are failing. So we need to replace the roof with a new roof. It is a huge dollar figure. It's about a $20 million roof. The windows, most of the windows are original. That means windows are single pane. They've got caulking on the edges. There's no gasketing in between the 2 panes. They're in tough shape. And then the HVAC is probably, to me, the most fragile system that's out there. They range from 65 years old to 25 years old. And the stuff that's out there that's 25 years old wasn't built to last this long. So we're replacing parts and pieces and equipment constantly. And what we're running up against is that they no longer have some of the parts on stock. They stopped making those parts because those things have been outdated a decade ago. But we still have them operational. So we're still struggling to find parts to make those replacements. There's going to come a point in time where we just can't fix them anymore because we won't be able to get parts. So the good news is that all rooms get heat. I would say that there are minimal spaces that have air conditioning. It's mainly associated with teacher prep spaces, not classrooms. So classrooms in general, with the exception of the K-mods, classrooms in general do not have air conditioning. First floor, second floor. When it's 90 degrees outside, it's typically warmer in the classroom because of all the bodies. So in my professional career, I've actually built 2 other high schools. One was a renovation addition on site, and one was build a new building across the site. So both scenarios is what Lexington is contemplating right now. The building, the renovation, and doing the addition while students are in the same building was significantly more challenging. We had students that found their way into the construction zone. It's noisy, power goes out, water goes out, vibrations, smells. We impacted MCAS testing on certain days. You just can't have steel erection be quiet. That's not something that can happen. There's not enough, there's too many quiet days for testing and all of those things because testing happens almost every single day. You can't just stop construction and let that activity take place so that teaching and learning can happen. It impacts the students and the teaching every single day. So the new one on the opposite side of the site, which is one of the options that we have here in Lexington, is a better option. We get to keep all the traffic, the dust, the noise, the vibration to a minimum. It won't eliminate it, but it makes it a much, much more pleasant experience for teaching and learning. The construction folks are on their side, the student and teachers are on the other side, and they're separated by a fence, and that's really a much better situation for everybody. There's 2 projects that are proposed. Renovation on site with all the students and teachers happening, and then building a new building on the fields. In my personal opinion and my experience, building on the fields is faster, it's easier, it's less expensive, and in the end, the product that you get is a brand new building that'll be around for 75 years. When you renovate an existing building, you still have the old building. Once a final design is selected and the designers are working toward that, I think the biggest effort for us is understanding the design and looking for every single opportunity for value management. How do we have some cost savings from the schematic plan that we have now to the schematic design that we'll have at the end? So that really is the opportunity for the school building committee at that point, is to educate folks what the project is all about and look for every value management opportunity that we have. I think there's a couple things that we learned. Number one, that the fields are a real sacred element to the community. And that is something that we knew, but we didn't really know the intensity level. And so we've tried to do with that information is come up with a design that stays off the fields and has as little impact as possible. When we first started this, we knew that we were going to have 5 or 6 years. We weren't going to use any of the fields. They were going to be offline for the contractor. At this point, there are some proposals out there and a couple of design options that really allow the fields to stay partially in place, and some of them for the whole time. And so the architects really have heard the feedback from the community about leaving the fields as untouched as possible, and some of the designs reflect that. One of my responsibilities is to bring capital projects forward. So at this year's annual town meeting, one of my new capital projects is to renovate the high school. So I'm bringing a capital proposal to town meeting for about $300 million to renovate the existing high school. Please understand that that does not add any square feet. That it replaces the roof, it replaces windows, it replaces the HVAC. It does some finish work because we're going to rip walls and ceilings down, but it won't do a significant amount of effort to fix the square footage problem that we have. We will still have 2,400 kids in a building that's built for 1,850. So that's coming. That's going to be at fall. I mean, at Springtown meeting. In the event that the town decides to build a new building, I'll withdraw that particular capital request. But if town decides not to build a new building or to build a new building on site, then I'm going to push that project forward because we still have to fix that building. Right? We're going to struggle to get this building to make it to 2029 as it is.